Problem number 2. So a town's population has been growing linearly. So they're actually telling us here that we're going to be using a linear model. In 2004, the population was 6,200. And by 2009, it had grown to 8,100. Predict the population in 2013 and identify the year where it will reach 15,000 people. Again, try to do this on your own. Pause the video and come back. Don't forget to identify and state what the variables are and what they mean. Try to use meaningful variables. So here we're dealing with time. Try to not use x here, and the function is, well, try to figure out what the function is, but what it represents. Try to use a letter that's related to the word it actually it represents. Okay, so here we're dealing with population and time, so it's logical to try to use t for time, p for population. So I'm going to start my solution with that. So let t. Now what's going to be t? Is that going to be the year? Could be. Could choose like t represents the given year. But I prefer here, since we're starting to record the population in 2004, maybe start with the number of years that have gone by since 2004. I find that easier. So time, so this one, I'm not going to be dealing with t equals 2006 or 2008 in my input, but I'm going to be dealing with 0, 1, 2, 3, 4. I find that more convenient, but both are okay. Time in years since 2004. Okay, so maybe just so t equals 0 means 2004, so January 2004. P of t will be the population. Let me try to spell this correctly. Population at time t. I'm not going to say at year t, because t is not, it's not a number of years after 2004, so it's not actually a year. So I'll just write at time t. So this is in years, right? Well, t's in years. I should have. So never mind that. I wrote that t was in years before. So we're given that this is a linear increase in the population, right? It's been growing linearly. So if this is t, initially it starts at 6,200. Well, maybe actually know what my axis here. I could just write it like, this is just to say that it's a truncated axis. So I'm just not indicating like the earlier parts of the axis. So close to 0, I don't care. I want to start at 6,200. So this point is actually 0, 6,200. So we start here, and then we increase linearly. And maybe let's indicate like after 5 years, population has increased to 8,100. So I actually get, with my modeling here, 2 points on that line, and then therefore I can find the equation of that line, or their formula for P of t. So m here will be my the slope of that function. So it's delta y over delta x. So that's going to give me here 1,900. This is people, right? I'm just subtracting number of individuals or people, and below it's 5 years. I want us to pay close attention to the units here. So overall, when I do 1,900 divided by 5, you get 380. That's going to be people divided by year, so per year. So we see that the slope has units here, and the units are actually giving us a good indication of what that number means, right? So every year it's going up by 380. That's what 300 people per year means, okay? And if you think about it, the slope is, if you go forward by 1, this is how much and it tells you by how much you go up. So if you go forward by 1 year, you go up by 380 people, okay? All right. So P of t will be, well, I've got the slope, I've got the y-intercept, so I'm all set up. 380 t plus my y-intercept. So the data that I have allows me to write it immediately in slope-intercept form because I know the slope, I know the intercept. Of course, I could have, I could have used the other point to write down my equation in point-slope form, but since here I can write it in slope-intercept form, I prefer to use the intercept. Okay, and so by expanding this, I would get the expression above. But of course, both are okay. Maybe a quick note here: if you actually chose t to be the actual year, okay, which would have been like 2004, and here this is 2009, okay, and this of course would have been some truncated axis. You would have had here like a point that would have been 2004, 6200, and another point which would have been 2009, 8100. So your slope would still have been like 380 people per year. That's not going to change. It's still the same slope. It's just that you won't get a y-intercept of 6200. And here you probably will have used the point slope form here to get the equation of your line. So 380, and then you choose a point, something like t minus 60, t minus, let's say you use the first point, 2004 plus 6200. So that would have been the equation of your line, or you can use also the other point. So that's if t is actually a year, right? So a given year, and not the number of years that have passed since 2004, which is what I've chosen. Okay, so both are good. It's just that you have to be careful that you're not going to get the exact same model in that situation. So I'm going to keep going with what I chose. Okay, and so in A, what do we want to know? I want to know the population in 2013. So I need to know how much time has gone by since 2004. So I'm going to take the year that I have and subtract it from 2004. That's going to give me the number of years that have passed, and that's going to be my input. So I'm going to calculate P of 2013 minus 2004, which is P of 7 years. So 7 years have passed since 2004. So I just replace T by 7 into my function here. And then I'm going to get, by calculating this, 8,860 people. Okay. Common mistake is, if you're using the number of years that have passed, is to actually use 2013 as your input. And if you do this in my model, you're going to get something like a really, really large, and you should actually tell that this doesn't make sense. So you can't, and by growing by 300 people for a year, start with the 6,200 individuals, and in what, 7 years get something like that's above 700,000. That doesn't make sense. Okay, so you would, of course, in the blue model, this is actually what you would input here. You would put actually directly 2013 in there. But look what it's going to do when I replace T by 2013. I'm going to get exactly the same thing, right? I'm going to get 380 times, how many years is that? 7 years plus this, right? So I'm going to get the exact same thing in both cases, right? Those are exactly the same. But the inputs are different because I'm measuring things differently. So in my case, no, that's not right here. Okay, so what I calculated first was correct. And let's do B. B, I need to figure out how many years it's going to take to get a population of 1,500. So I'm going to solve. P of T equals 1,500. So that's 380 T plus 6,200 equals to 1,500. And that's just a linear equation to solve, so no big deal. So 380, I subtract 6,200, you get 8,800. You divide by 380, and you get approximately 23.158 years. Okay, so if they were asking us like in which year, so so maybe I can write down as in a sentence here, the population will exceed 15,000 people, and well, I add 23, right? I do 23 now plus 2004, that's 2027. That's it. That's my answer here.